I'm Newton, Chu.
And I'm Roberta. And we're here, well, I just, I'm like really quick, we gotta talk about this. But a year ago, we unfortunately lost Paul Coleman, who was, I think, the first Hawaiian astronomer that worked for University of Hawaii Institute for Astronomy. And it was my husband's great idea to start a scholarship program. So why don't you tell us?
Okay. Paul Coleman was a great guy. He's very inspirational. He was first day in Hawaii to earn a PhD in astrophysics. For the past 15 years, he worked at the Institute for Astronomy at the University of Hawaii, Manoa. And he worked tirelessly to encourage kids to pursue astronomy. He tried to build bridges between the Hawaiian community and the astronomy community. And unfortunately, he passed away unexpectedly at a very young age. And Paul was a very special person, very inspirational. And we just so happen to have a son who's interested in astronomy and is pursuing a career in astronomy because of people like Paul. And so we thought, oh, to lose a leader like that is really a shame. So what we need to do is continue his legacy and get more of our Hawaii's youth into this pursuit of the sciences above the clouds. And that's a lot of what astronomy is. It continues the Hawaiian tradition of exploration. And since a lot of the most important astronomy is done here in Mauna Kea, the children of Hawaii who decide to stay in Hawaii and attend University of Hawaii at Manoa or Hilo can now qualify for a scholarship called the Paul Coleman Scholarship.
Undergrad.
For undergraduate studies in astronomy. So tonight is it's a great segue that if we have two potential students who are going into astronomy at the University of Hawaii, we would encourage you to look into this scholarship for the UH Foundation website and tell you how to apply. And we hope it helps. And we encourage you and others to pursue this, and it would just warm our hearts if you got a scholarship.
Yeah.
So best of luck to you. Congratulations on being a Maunakea Scholar. Mary Beth. And Mary Beth.
Yes, I will say, Newton, when is the application deadline?
It's right here on the website, which I'm going to read to you right now.
All right.
It's the preferences to graduates of a high school in the state of Hawaii.
Okay.
You're an undergraduate level, Hawaii residents full-time. This is where you send an email to star.hawaii.edu/scholarship. Okay. It doesn't say when there's a date. I think I'll tell them to keep it open for you, okay?
Apply.
Apply.
All right.
Thank you.
Thank you, Newton. All right, Doug's going to get me set up while I say thank you again to Newton. And so at the end of the evening tonight, we actually have the Hōkuala Scholarship, which is for Maunakea Scholars students that have just completed their senior year of high school. So we want to get them to Newton and Roberta. So it's my privilege to be able to speak first today. I'm Mary Beth Laychak, the Outreach Manager, Canada-France-Hawaiʻi Telescope. I see Fritz walking over because apparently I don't need the extra volume. And so I'm going to give a brief, just sort of overview of the program for those of you that are not familiar with it. If you've seen my talk before, please bear with me. I added new pictures of new kids and updated my statistics. After I'm done, both Ronny and JC will speak, and then Doug will bring the evening to a close. So I'm assuming this is working. All right. So what is Maunakea Scholars? It's a student-driven research project for Hawaii public high school students. And the really important words I have in a separate color blue here, student-driven and own research. So the students are the ones who actually drive the program. Ronny and JC both develop their own projects, their own proposals. These are their ideas. One of their mentors is in the back here, Christian. Christian worked with JC, and he's living in Hilo now, so he stopped by for the evening. Christian did not tell these guys what to observe. He didn't offer any sort of like, this is what you should do. These projects were driven by students. And that's what makes the work even more remarkable. This is not something that Doug or I or Christian came up with. This came from the brains of our local kids. One thing that I also want to highlight here is Hawaii Public High Schools. We work exclusively with Hawaii Public Schools. We're bringing a charter school, Kapolei Charter School, on board this year for the next school year. This is really important to us, is that this program is available for our public high school students. So often I feel that they're kind of overlooked in the grand scheme of things. When you go to the science fairs, a lot of the private school students have opportunities that our public school kids don't have. And so I both very strongly believe in public education, as I know Newton and Roberta do as well. We've got parents of Waipahu grads, you won't be surprised. Hilo, I'm so sorry. Oh, the fight words. You notice who's not on my project though, Hilo. So these are the schools that we've worked with. You'll notice that we're on every major Hawaiian island. If I can find a way to meet you out, please let me know. That's the one island that I am not currently working with. On the big island here, we have Kealikehi, Maunakea, and Kahala. Kealikehi runs in a very interesting way, which we'll talk about later. On Maui, Kincaid, Kauliki, Mulukai, Lanai. My Lanai students this year were actually middle school. So they didn't receive telescope time. We have rules, you have to at least be a freshman. But the amazing thing about them was they were the first students ever to, from Lanai, to attend the district science fair. And they used archival data from the CFHT data archives, and they had these wonderful projects, and we're hoping that they start the trend of being, students who continue to go to the science fair from Lanai. Work with Kalani High School, Waipahu High School, which is where JC is from and representing today. Kapolei High School, Ronny's alma mater, was one of the first schools that we worked with, along with Maunakea High School and Kapa'a on Kauai. So these are our kids. The process is pretty straightforward. I'm not going to go through all of this, but I pair the school with a mentor. All of our mentors are graduate students. Well, most of our mentors are graduate students from IFA Manoa or UH Hilo or IFA Hilo or whatever Institute for Astronomy in the University of Hawaii system they will give me access to the grad students for. I pair the school with a mentor and they work together over the course of an entire school year. So we work with these students for at minimum one school year. The first time I met Ronny was August of last year. Went to his class with Ms. Gams, who was one of our very first teachers. I've actually been working with JC for 2 years. Ms. Ford, I worked with her before she was Ms. Ford. Ms. Ford invited me over and I worked with him for 2 years. I provide an introduction to the program and then basically let the kids run loose. They go and research topics that are interesting to them. I know Ronny's going to talk about how he became interested in dark matter. Similarly, I think JC is going to mention his interest in hot blue stars. And they just kind of run with that. And then the students write the research proposals, and myself, Doug, and our astronomy group manager, Dr. Nadine Mansett, sit around Doug's conference table, and we review every proposal that the students write. So the students really only compete within their own cohort. This is actually the first time that JC and Ronny have met. Their proposals were not evaluated against each other's. The Waipahu proposals were not evaluated against any of these. It's really important to us that each school has a student or multiple students that receive the telescope time. There's nothing worse than doing all of this work and having someone on a distant island win. That sort of defeats the purpose of what we wanted to do. We wanted to empower these students to see themselves as people who can achieve in STEM at any level. After that, we get data. I'm in the process of getting data for both of them right now. And then everybody who submits a proposal goes on the summit tour. If it was that simple, it would be that simple. Ronny's group made it most of the way up, and then we had exceptionally high winds, and they couldn't go above Haleʻuahu. JC's been to the summit twice. Once was with a 6.9 earthquake, which I think was more terrifying for Doug and Miss Ford and I than him and his classmates, who were like, this is fun. Like, we have children, they're not ours. And then we, sometimes we work with students for a year. In the case of JC, 2 years. I had a student who just graduated from Maunakea that we worked together for 3 years now. So our selection process is based on feasibility, creativity, and student-driven data. The very first one is where we lose most of our projects. So what seems to be straightforward and simple is not. So we have students who have wanted to do projects and we're like, yes, that is a PhD thesis. You need 5 years to do a dark matter survey of the Virgo supercluster of galaxies. Or you want to discover and characterize the atmosphere of an exoplanet, as does every professional astronomer on Earth who studies exoplanets. We're not quite there yet. So that's where we lose most of the proposals. Many of them are just too ambitious, they're too cutting edge, they take too much time for us to be able to execute in the 1 to 2 to up to 6 hours of telescope time we have. The creativity is never an issue. I like to tell the students on the very first day that you hear the phrase, you have to think outside the box. That only works if you have a box. These are high school students who know nothing or very little about astronomy on the very first day when we talk to them. They create their own box. So they're really not constrained by the thoughts that professional astronomers have, which leads us to some wildly creative ideas. One of my coworkers, Cam, he says that these are some of his favorite projects to actually observe because they're so different and they're doing things that he's not seeing anything else. It's also always really easy to tell if a student likes their proposal or not. I talk to everybody over the course of the semester or the year more than once. And so I'm pretty good at figuring out if the kid's interested in their topic. We've actually had students who in their proposals write, I wasn't really interested in this topic after I picked it, and now I wish I'd chosen something else. We've had 1 or 2 of those. That's when you get done and laugh. So this is my cohort from Maunakea High School this year. So it's interesting at Maunakea is that these are all the winners there. You notice this is a huge number because I work with 3 classes there. At Maunakea, we work with the credit recovery program. So these are students that have struggled in science. And the idea is that there's a huge difference between learning science and doing science. That if these are students that learning science isn't connected, what if we have them actually do science? And this group had some really fantastic ideas. I think half of them wanted to look at Jupiter. We had our first 2 fully solar proposals, but we have to now find a solar telescope for some of these kids to observe on, for kids that want to do solar work in the future. Here you see JC along with Danny and Giraldi. These 2 made it to the district science fair. Giraldi has now majoring in computer programming. He discovered a love affair in computer science with astronomy is like the stuff you put in. And this is Danny in the middle. She's a junior, so we're going to be working with her for the next 2 years, or the next year. This is Grace, who is at Hōkuala High School. She's our first winner from Hōkuala High School. And for her proposal, we actually had to go international. We emailed that she wants to study magnetars, which are a very specific kind of pulsar, and we had to go to McGill University and to talk to an expert there to see what was feasible for the idea that Grace had, and she was offered to help assist Grace with the data if necessary. This is our King K cohort. These 2 ladies were, I like to call them my solar system storm chasers. They've now wanted to study storms on every gas giant planet except Saturn. I feel like if they had been 1 more year in college, in high school, they probably would have thrown Saturn in there as well. This is my students from Maunakea High School. So this is Megan and Gretchen. They are all studying Pluto in different ways. So Megan and Gretchen want to know about climate change and how the warming of a planet affects its atmosphere. Now, Pluto, as it orbits the sun, it has this highly stretched out orbit. As it orbits the sun, it will change temperatures. So we're not looking at person-made climate change. We're looking at what impact does the sun have. This is Caitlin. Caitlin wants to be a doctor. I've been working with her for 3 years. She is interested in biomarkers and where life and water in the solar system could come from. If they look familiar, they are related. Megan and Caitlin are sisters. They're our first winning sister pair. And then here's Giraldi. Here's Ronny. Our award ceremony for Ronny was actually at 9,000 feet at Halepuaku. This was as high as he got that day because, again, the high winds, we had to head down. So our Maunakea Scholars really run the gamut. One of the things that makes the program very unique is that we don't dictate to the school where they're going to place it. We work with Ronnie's teacher, Ms. Gams. She has an Earth and Space Science class where she's basically built her entire class around this course, and Ronnie will talk a little bit more about that. With JC and his sport, we're working with an AP STEM research kind of thing where half the class was interested in engineering, and I have like the diehard astronomy people in there. We work with credit recovery students, research classes, after school astronomy clubs, and really wherever it fits with the school. This is my Maunakea kids from 2 years ago. They are up at the summit, and I always like to point out this is Mr. Mack. If you were familiar with the inspirational story of Molokai Robotics Club this year, they won and qualified to go to the World Champions, but they didn't have the money, and thanks to Hōkuala High School and a lot of donations on GoFundMe, some of those donors may be in this room, they actually went to Worlds, and Mr. Mack was one of their advisors, and they won the best rookie program. And this is a school that, may I say, Honolulu Magazine rates an F. I would highly disagree with that assessment. So, like I said, each school has the freedom to fit the program into their curriculum. So, as you look at this list, you see this is every facility on Maunakea. RoboAO is in this kind of funny color because it's in the process. We have been working with them when it's a UH project when they were in Tucson at Kit Peak. They moved that whole thing over, and I don't see Christoph, who usually comes to these. They're rebuilding it on the 88-inch, so we're also using the UH 88-inch. And LCO worked with JD Armstrong, and that one's over on Maui. So this is actually the one that Ronnie's going to be using. So in summary, in 4 years, I have 12 schools, roughly 530 participating students from 2015 through now. I say roughly because sometimes kids drop out of a credit recovery class. It's probably not shocking. Sometimes we see the same kids for year to year to year, and I'm not quite sure how to have them. We've had 77 winning projects. I know that number is correct because I added it up today to update these statistics. And we've had 12 mentors from UH Institute for Astronomy, in addition to a handful of mentors who are not graduate students. So what's really important and what makes it really appropriate that we're here at Iniloa is that Iniloa helps us root this program in a sense of place. So it's very important for us that students across our island chain really understand Maunakea and its significance to Polynesia, to voyaging, to wayfinding. But why we would be crazy to invent our own program when we can use Iniloa's motto, the modern ancient way of navigating our universe. And so this was a program that started here by Ceci. She's now at Kamehameha Schools, and we're stuck with Kalepa Babion. So Kalepa and I travel, and for those of you that don't know him, he's a master navigator, 40 years in navigation, and navigated Hōkuala on many legs. When I go to these presentations with Kalepa, I like open and close the dome. It's great. I learn a whole bunch of stuff. They'll do the entire program in Hawaiian. We've done that for a couple of Hawaiian immersion schools. He talked to the entire island of Molokai, I think. And so he talks about voyaging and navigation and really the importance of math in navigation. When we did this with the students from, actually, this group of students here, this is Kalepa over here, he bailed Doug and I out. You don't see the mountain from Hilo Harbor, Hilo Bay, because it was snowing. And if you've ever thought about the idea of telling a whole bunch of high schoolers the field trip is canceled, you're not going to do that. So we had to figure out a field trip since we couldn't go to the summit. So we toured a couple of facilities here in Kona, and then Kalepa took us on Hōkuala when it docked at Hilo Bay. And the students in my van, driving a 15-passenger van filled with high school students, and one kid's like, I didn't know like you used math for stuff. He was just blown away by the idea that the Kalepa and the navigators would have to use math and how vitally important it is to all of that. And you could hear the wonder and awe of like math has a purpose in his voice. So that's the end of my spiel. I'm going to do a brief introduction of both of our students and their projects. So we're going to start off with Ronnie. So this is what Doug does. This is how Ronnie found out that he one telescope time, there was a blank frame, and Doug clicks this, and it comes up, and I was like gasping, and he was really excited, and he'll talk about that. And so his project was on how does dark matter affect a galaxy.
Have you ever had the feeling that there's something bigger out there, something you can't see? Well, there is. It's called dark matter. Dark matter is spread throughout space, both in the Milky Way and all other galaxies. It's 4 times more common in the universe than visible matter, yet we've never seen or directly observed it. So how do we know it's there? Because of gravity. A galaxy is like a giant merry-go-round that all the stars are riding. In order to stay on, each star has to hold on tight. That's where gravity comes in. Otherwise, it'll fly off into space. The problem is, the force of gravity from all the stars we can see isn't strong enough to hold galaxies together. All the stars should be flying off the edge of the merry-go-round, but they're not. It's as if some invisible rope is helping them hold on. Physicists believe that rope is the gravitational force from stuff we can't see, hence dark matter. And how do we know the speeds of stars in distant galaxies? The Doppler effect, which is why police siren shifts to a lower rate as the car passes, also works for light. That's how radar catches you speeding, and how astronomers measure the rotation of galaxies. So, we use what we can see to tell us about what we can't.
So that was so that you're all caught up to where Ronny is right now. I didn't want you to like be embarrassed when he starts talking, you're like, I don't know what he's talking about. We all now understand dark matter, we can keep up with Ronny. And so he had requested Gemini time, but he picked a really bright galaxy, so he's going to be using LCO over on Maui. And he's going to actually, I'm going to let him tell you what he's going to be doing, but this is an example galaxy. We'll see Ronny's galaxy in a bit. Now, this is Ronny actually using our telescope. So he actually got to open and close the telescope. We didn't really observe that night, because again, super high winds. But he got to sit in the driver's seat and do some really fun stuff. As did JC, so this is JC here. He's sending observations that aren't his, because he was, the day that we were there, he's using another telescope. He used us last year. He's using the NASA Infrared Telescope facility this year, so he's hanging out, observing with some of his classmates. And so JC is a 2-time winner. So his first project was our LVB stars connected to Wolf-Rayet stars to prove evolutionary process. LVB is a luminous blue variable. And so he used Esperance, which is our spectrograph, to actually look at the rainbow of these stars to figure out if they are, he's comparing them, because I'm not going to go into too many details. He compared. I'll let him tell more later. And then he decided, like, a week after he got his data, he emailed me. He was like, hey, I feel like I need more data. So we put another proposal in, and he got more data. This time, using the NASA Infrared Telescope facility, because, I mean, you can only look at stars in the optical for so long before you decide to have to switch wavelengths, which is what JC decided. So with that, that's he's the second student in the history of the program to receive observing time twice. I think we're up to 5 now, but his award ceremony was first. He's the only one who wants to major in astronomy in that group. So I'm going to turn the mic over to Ronny. This is the galaxy that he chose to observe. So Ronny, come on up. And he is going to talk to you about his project.
Right there.
Hi, my name is Ronny Whitter, or Ronny Whitter. When I started going to high school, I didn't really have a set career in mind of what I wanted to do. I did know that I wanted to go to college and get a better education so that I could get more job opportunities. So yeah, but it wasn't just that. I knew I had an interest in computer science, and so if I didn't find a career I wanted to pursue by the end of high school, I would have just studied computer science in college. With that in mind, I went into my freshman year. I'd say that was a pretty normal year. However, in my sophomore year, I was gone from school for 2 weeks on vacation. And after I came back, I was gone for another 2 weeks because I had an ACL surgery done. And so that month I was gone from school, I really felt behind, and it was really hard catching up to my classes. But I picked myself up in my junior year. I studied really hard and I did all my work, and so I got A's and B's again. At the end of my junior year, when I was deciding what class to take for my senior year, I was talking to my chemistry teacher, Mrs. Gams, and she told us, the class, to take her earth science class if we had a free period, because it would be at the end of the day and it would be a chill class. She told us that there would only be one project, the Maunakea Telescope project, and that if we took the class, we would have a field trip to the Big Island. And now I've never been to any other Hawaiian island at the time, so I was really interested to going to the Big Island. When the time came to choose what topic I was going to research, the only one that stood out to me was dark matter. There were other topics like exoplanets and black holes, but those topics were, I felt that those topics were well researched and well known, and so making a unique project out of that would have been kind of hard because you would have to do really in-depth research. And so I wanted to know how to find how much dark matter there is in the galaxy to figure out its impact on that galaxy. So our projects are pretty simple. We just went on to astrobytes and we copied down any information that we needed to help prove our proposal. And yeah, we copied down any equations, graphs, and stuff to help us. But after a few weeks, it kind of got difficult because there were equations we didn't know, and there were terms that we didn't know. And so Ms. Gams introduced us to our mentor, Travis Berger. Travis helped us out by looking over our proposals and telling us what we needed to improve on. He helped me out by telling me he helped me find another galaxy to research because the galaxy I originally wanted to research had already been researched. He also helped me update the equation I had because it wasn't correct. It wasn't the right equation to figure out how much dark matter there was in the galaxy. And so after a few weeks of revision and filling out all my information, I finally came up with the proposal of studying the galaxy NGC 4244. I would use the Gemini telescope and with the attachment of GMOS to look at stars at the outer slit of the galaxy, and I would use the equation mass equals velocity squared times the distance of the star to the center of the galaxy divided by the gravitational constant. This will allow me to find the total mass in the galaxy, and I will compare that to the visible mass of the galaxy, and by finding the difference, I will find out how much dark matter there was in that galaxy. And so I filled out my research proposal, and I filled out the telescope form, and I got that checked by Ms. Gams, and then sent it to Mary Beth. Fast forward a couple of months, and a few people from my class, and as well as some juniors, won the Big Island. And yeah, unfortunately, due to hirings, we couldn't go up and see the telescopes. But that day, I did meet Doug and Mary Beth. That day was really memorable because I wasn't expecting to have one telescope time, but to my surprise, my project was like the first one to have been announced in telescope time. And so I was really shocked and I felt honored to have won. And so I decided to pursue astronomy because I feel that this field is really interesting and that you can never get bored researching space.
All right, stay up there, Ronny. So tell everybody how it felt when you got to operate the telescope.
It felt really cool. Also, I was really nervous touching the wrong buttons, but it really helped me out. It was really cool.
And where are you going to school next year?
University of Manila.
Yes, and you're studying?
Astronomy.
Right. Right. Excellent.
So thanks to Ron, I was like really impressed because he emailed me, I was like, so when are your slides? He's like, I'm not using slides. I'm like, ooh, I like that. That's a bold choice. So another round of applause for Ronny. So our next speaker is, and so I will mention Ronny and his data. We'll be taking his David UH with him, starting his freshman year with David. All right, our next speaker is Jean-Claude, who prefers to go by JC. White WHN stars, possible precursor to the mysterious LVB stars. You'll notice there's a lot of letters in there that hopefully JC will tell you all about. So come on up.
The thing, yeah.
Oh, nice.
So you just rock that like a pro.
Okay, so to reintroduce myself, my name is Jean-Claude Dumaslan. Well, as my friends call me JC. The presentation or the project that I picked, the title was WNH, also precursor to the series of LED stars. So that's a lot of information that I told you that you probably wouldn't even know what that's about. Well, I didn't even know what was that in the beginning. I'm still learning more about them. But I'm gonna take a little step back and explain how and why I picked this topic. So, Miss Luma, or Miss Gordon now, so she got married, one of her class assignments, since I first joined her class, was to pick a picture for the Astronomy Picture of the Day, which is a website from NASA where they post pictures every single day. And we were to describe why we like this picture. So I just picked a random date and I saw November 1, 2017. And when I picked that date, they had a title called NGC 2359 for Summit. And at that time, and still now, Marvel's pretty popular, so I was thinking forward, why not? And so when I clicked on it, I was amazed at how just a star was able to do this, just doing what it normally does. Well, normally what that star was. And so I looked at this description and I started talking about a Wolf-Rayet star and what was a Wolf-Rayet star. So I looked more into it, and as I looked more and more into it, I started learning more about it. Then I stumbled upon research papers talking about how a Wolf-Rayet star can become a luminous new variable star. I was like, what? I knew about the evolutionary stars before, but I never thought that these two rare types of stars could become one another. And so, from those two, I tried to, for my project, I was trying to look for something to find similarities and differences between them. And the only thing I could base it off was a description of them. So basically, a Wolf-Rayet is just a massive star, has little to no hydrogen, and is burning all the heavy elements within it. Normally. Note that normally because I'm going to talk about that later. And each of those Wolf-Rayet stars have their own categories where it's based on how much of that certain element it has. And the one I'm focusing on is nitrogen. The other star that I was talking about was luminous blue variable, which you can kind of get off by the name, luminous being bright, blue being the color of the star, and variable being varying in its magnitude spectrum. So going back on the normally, as I said before, there's little to no hydrogen, but there's a subset of those Wolf-Rayet stars where there are still hydrogen. So in order to be stable enough to become another star, you need to still have hydrogen within it in order to transition. And so, using the Canada-France-Hawaiʻi Telescope, I'm using the Esperanto machine or instrument to get the spectrum, I was able to see data on 4 different types of stars. And doing that, and with the help of my mentors, I was able to graph them and use it to compare and contrast between those graphs. The main part that I was trying to look for in my project was an H2 region, which is just an ionized region in a visible color spectrum where you can find hydrogen. So if you can find more hydrogen in its density, the more hydrogen it has. And that was what I was looking for. And so when I did, I saw that my data, which my LVB star had more hydrogen than I thought it would be. Way much compared to my Wolf-Rayet stars, where there's a carbon one and a two nitrogen ones on the bottom. And that threw a wrench at my project because I didn't know what to do. So then I started noticing that the nitrogen one started to have, or the nitrogen one had a higher H2 compared to the carbon base. And so when I was talking about the W and H, the W meant the Wolf-Rayet, the N started for the nitrogen, and that lowercase h was the hydrogen. Meaning I was getting closer to my goal, but I wasn't there yet. But using what I had now, I was able to bring it to my school, school science fair, and I was able to go into my districts. And there, this is where I was able to meet people who was in that field, who understand what I was talking about. There was one judge, this lady, she walked up to me, and she was one of the only judges who told me that my project was okay, but not good enough. And from that, a week or a few weeks after that, I felt kind of sad about that comment. Because we started talking about, I'm missing variables in your project because I never accounted for the age of the star or how fast it's spinning on its axis. And after that few weeks of sadness, I started getting excited again. Because that meant I had a lot more to learn. And knowing that I have more time to learn since I'm going into college, I'm planning to use that. I'm planning to still research more about my project going into UH Manoa. We're majoring in astronomy and astrophysics. And I hope when I get the NASA data, or the RTF, which is a telescope that helps study the infrared, I'll to use that points that the judge told me about and help better my project. And with that, again, my name is Dumaslan, and thank you for listening to my presentation.
Because I wouldn't have said that. Thank you. So how did you feel having being able to use CFH to make someone else's video?
It was really nice knowing that I was able to help someone, even though it's not my data. And it was fun to just creating it. That was it, it was just cooking. But I was still afraid that I might click something and it might break them.
We do reassure them that they can't break anything, but it's very much a fear of students. So another round of applause for JC. All right, our last speaker is Doug Simons, the director of the Canada-France-Hawaiʻi Telescope, and I don't know what his plans are. Well, I do, so I'm gonna go have a seat. He's gonna talk about stuff, and then he's gonna make a scholarship announcement.
So poetic. Okay. So first of all, JC, that thing about being wrong, most of my PhD thesis was wrong. And here I am as a director of observatory solar about it. Teach broccoli, keep firing away, and we'll be fine. I gave a long presentation last year, so I'll spare you that. And all the few slides focus mostly on the award that we're going to provide tonight for a scholarship. And before I do that, I always look forward to the opportunity to making my partner in this crime turn different colors, which you would never show these slides, but I want to share with you some recent recognition across the state that Mary Beth has received as a result of her very hard work over the past 4 years in this program. Picture on the left there was last Friday over in Kona, the Hōkuala Chamber installation. There are 350 people there, including the governor giving a keynote, and Mary Beth received the Hōkuala Community Education Award for her very hard work in establishing the Maunakea Scholars program. I thought it was particularly fitting because it's the Waipahu High Award, which is where she resides and puts so much effort in. The other one was a few months ago, and this is the statewide one. This is the business news, 40 under 40, or someone pointed out he didn't. So I had to go through the 60 under 60 or anything like that, one to 40 under 40. This normally goes out to, I think this is wrong, but bankers and realtors and people like that. So I have an outreach person from astronomy who received this award in Honolulu. It's like an alien touching down, so to speak. But it was a real thrill for the whole group to assemble in Honolulu around our table there. And I wish Mary Beth well in that as well. So I just want to point out that the work that she's doing, because it's a statewide program, is getting a lot of recognition by various organizations around the state. It's very much well deserved. So this is me in contrast on any given day. I feel very much like that after today. I'm working on other things that you can imagine right now. And this is a segue about the tracks that we're laying from one part of astronomy, education, and workforce development to another. And the first set of tracks there is all about working with kids in K through 12 in particular. This is the area that Mary Beth in particular focuses on, is the Maunakea Scholars there. We also journey through the universe, which basically jump-started Roberta's son in his interest in astronomy. Of course, Astroday, which has East and West Hawaii, is leading the charge with essentially all the observatories working in collaboration here in Hilo or over in Kona. So we have an enormous number of programs, over 100 programs annually that are launched across the Big Island regarding K through 12 astronomy for students. And then at the college level, you have the Akamai program, which is, I'm on the granddaddy of all the internship programs. I would even argue in the state. So we most well established in the observatories. We have about 30 or 40 kids this year, I think. It's 3 or 4 interns at CFH. These are mostly filled by the Maunakea observatories that we have some now on other research facilities around the state. And these kids are just super top-notch. And basically it's open to any students that reside in Hawaii, that can go to college anywhere. So keep that in mind, you two, being astronomy majors, you're going to have a super wide front door for this program. They actually pay you, and it's about a 10-week long, fairly intensive program to do research and buttoned up, I would say, by some of the best presentations I've seen by these students. There's a program, I think it's actually here in Hilo, one in Waimea Tech, and maybe over Maui as well. And it's also TNT, also capacity. And then Think Fund, which Roberta and I have been involved with from the get-go, and Waipahu Foundation provides scholarships. A lot of scholarship money has been provided. And then to seal the deal, you actually have to hire these kids. So they go K through 12 in college, and you gotta actually show the money, so to speak, hire them. And here's some relatively recent hires at CFHT. This is represented by the other observatories as well. I've got a window there who, on the top left, is a master's in mechanical engineering, which Manoa, where you guys are going. To Eric, who graduated from HEC, he's our internet guy, our guy who runs around and fixes my computer, basically. There's Callie and Cam on the bottom, so they are both UH astronomy graduates of the program here. And they actually run the telescope, which is kind of scary for an old guy like me. These kids coming out of school and running multi-million-dollar piece of equipment like that completely on their own. They do a wonderful job, though. So it's an end-to-end program, and I hope I can, nothing else will help you get a little appreciation for the magnitude of what we're trying to do. This set of tracks right here is what we're specifically trying to sort of bind together to get kids from high school and leaping into that critical first year of college through this particular scholarship that we started. So we actually announced this last year, almost exactly a year ago. It was not pre-announced in any way. We also sort of shocked the blank out of the first awardee because she didn't know that even the scholarship existed, that the one that she wanted. She's majoring now at Hilo after receiving the Hōkuala Scholarship for the first time. This is our second year around that we are providing this so-called Hōkuala Rising Star Scholarship. It's awarded to one of our top Maunakea Scholars that are interested in pursuing a career in astronomy. So you have to be a senior to apply for this, obviously. Qualifications are fairly standard for these things, except that tends to be more specific to astronomy. So GPA requirement, those parents in the room will recognize the dreaded EFC acronym. Caliber Maunakea Scholar research projects that they completed, and then a all-important essay. For me, that's actually really important, that they describe their interest in pursuing a degree in astronomy. It's a $10,000 award. It's available to use on any college of their choice, wherever they want to go. And like I said, it's very useful for that first step getting into school, when you launch from there with the scholarship potential. And for students attending UHU or Manoa, it comes as a package in the sense that you will also be paired up with a mentor to help you through your college as well, which I wish I had as an astronomy major at Caltech. We didn't have mentors, we just had free flights. And it was a lot of ways to get a future degree. So this scholarship works hand in hand. I'm really glad that you referred here with the Hōkuala Scholarship. This gets them into college, and then their scholarship keeps them in college because it's recurrent and endowed scholarship. And I strongly urge both of you to apply to the Hōkuala Scholarship next year. Not to mention the Think Fund, which Roberta and I, there's so much coercion going on. We're trying to lay a path of cash that you can walk across so you get to college and help you out with your strong ambitions. So without further ado, I'm very pleased to announce the award for the second Hōkuala Scholarship, and that is none other than our own JC, who is with us tonight.
Horrible people. Ronny has known for like 3 weeks that he was not going to be winning tonight, and he came anyway. So let's give Ronny a big round of applause for speaking. We're not horrible.
So,
Anyway, so nice. Thank you.
yeah, issues.
All right, you should look at the stage.
So this is a picture of your, so you got 3 of these now, these framed awards. And it reads, for outstanding accomplishments in the Maunakea Scholars program, including being the second student to receive 2 allocations in the third time history program. Maunakea Scholars program is delighted to award Jean-Claude Dumaslan a $10,000 scholarship to use at college's choice to advance his ambitions in the field of astronomy. So I won $10,000. Everything about this program is kind of personal. I won back in 1980 a $10,000 scholarship in this science fair program. That was absolutely essential for me to get to and through college. So I made a commitment every year to give $10,000 to one or more students as a way to start getting it forward. So when you're at my seat and you're a director one day, remember that. You pass it forward too. That's right. You'll be fine. So congratulations. You came in here today. I'm not quite sure what's going to happen, but you're leaving $10,000 richer for your efforts in the program, and I can't tell you how pleased I am to be able to help out in some small way with your ambitions. So this is a long-term commitment, and Mary Beth texts students that have been through the program like all the time. It's fun to watch her, build these friendships with students right through the time that they're in college as well. So Newton said it before, we are literally creating a whole generation of explorers. And it's not just a feel-good statement. I'm watching it happen. We've got 500 kids do this. You see sort of the top ranks here. We are easily creating enough interest in this program, combined with the other efforts going on, to essentially ensure that we have a lasting in-state, sort of in-house establishment of students and researchers and engineers and technicians, et cetera, to keep the observatories going for a long time, I hope. It's a wonderful time for a wonderful opportunity for me to sort of, the waning years of my career, what's left of it, to be able to drive this sort of program forward with Mary Beth. It really is a grassroots program. So I thank you for your attention tonight, for showing up. This will be on TV tomorrow, I think. It's being videoed, and you should hopefully see it on the Maunakea TV is pretty good at broadcasting this. And we should also get it in the local newspaper. So congratulations again to our recipient tonight and to Ronny for you in your wonderful presentation. Good luck with your adventure at Manoa. I'm a grad too from Manoa, so it's not really scary to help. Thank you, everybody.
So we have time for questions. If there are any questions for any of our speakers tonight, whether it's Roberta, Mary Beth, Ronny, JC, or Doug, I don't need to be up here holding the microphone.
Do you want me to take it? You're like gesturing.
Sure.
Oh, no, I love the mic.
I'm kind of embarrassed because I said we'd go till 8:30 tonight and you're done at 8, so I don't know what to say. Any questions? For any of our speakers? So I guess I have one for both Ronny and JC. What exactly do you, I know you're going with astronomy, but what aspect of astronomy do you know what you might be interested in studying?
Go for it, Ronny.
Go for it, Ronny. It's all yours.
Maybe like.
Yeah. He discovered that about 10 for the program. You can combine both of those.
Computer science side of it, the astronomy side. I have to agree with Doug, that's important still.
JC, what do you think? We sticking with LBDs?
I have 4 years.
Both good answers.
Awesome. Any other questions from the audience?
I'm just going to say that you guys, great start for you. When you start college, you never know what it's going to be like after you go through college. And it's a great adventure. Enjoy the journey. You're going to learn a lot of new things and just apply yourself. And I'm sure you're going to do just fine. Don't feel committed that you got to be chasing, find the answer to dark matter. You know, there's a lot of people who've been looking at that for a long time and still don't know the answer. But it's a great start. And just hope you enjoy the journey. Don't forget about the Kapolei Scholarship. It's available for you, okay? So good luck to both of you. Congratulations.
And I just want to add one more thing. So in mentioning that with the Hōkuala Scholarship comes mentoring. So Christian here, Christian can stand up. He's been working with JC for 2 years. You're not rid of him yet. He's agreed to continue mentoring you in college. So when that comes with that partnership, I would say, you know, Ronny, if you have questions, just email Christian too. I'm available, give me my cell phone numbers. But Christian, when I asked him if he would want to continue working with you, JC, he was like, absolutely. So that's why he came with me. So thank you. Thank you, Fritz and Maunakea Speaker Series.